Alright, welcome back everybody. My name is Dustin. In the last video, we added in the ability to open up file dialogues and we started the menu bar. So we started this so we can open up different file dialogues and do different things. So this is open up for PNGs. So let's run this here. We can also create our tiles and stuff like that. Currently, we can create our tile maps. However, we cannot save these tile maps and reload them. So it really makes this useless for us. So over the next couple of videos, we're going to start to create a couple different serializers that we can use to help us serialize all of our components and our tiles and other necessary data to files. Okay, so for this video, we're going to create a JSON serializer. And to do this, we're going to be using the Rapidjson library. The Rapidjson library is easy to use, and we're going to create some simple wrapper functions to help us serialize our components. That's the goal for the end of this video. We can easily add Rapidjson to our project through a VC package. So let's do that now. So I've already done this myself, but all you need to do is open up your VC package in the command line and then just say VC package install Rapidjson. Cool. So it's already installed for me, but you guys need to do that for you. I'll also be adding this to the build instructions at the end of the video as well. Awesome. Now that we have Rapidjson installed, as you can see here, we need to add it to our CMake project. So let's do that now. Okay, so let's first open up our main CMake and down here. So we basically just want to do the same thing here, and we can just copy this line down and then just change this to Rapidjson. Cool. So now that we've added it here to find our package, we need to go and add that into our Scion file system project. So we go to Scion file system, CMake list, and we're going to want to do the same thing here and just add in Rapidjson. Rapidjson. Now we should be able to use Rapidjson in our project. So the first thing I'm going to want to do is actually, if you remember in our file system here, we created a folder for serializers right here. So we're going to create a new file and we're going to call this JSONSerializer.h. Cache is not up to date. So let's make another thing here and we'll say Serializers and we'll just copy this. Paste that in. Serializers. JSONSerializer.h. Cool. So let's go back to this and say pragma once. So now we want to create our JSONSerializer class. We're going to need a couple includes. First, we're going to need an fstream so we can write to a file. So include fstream. And then we're also going to want the Rapidjson pretty writer. So include Rapidjson pretty writer.h. Not sure why it doesn't really see that right now. Let's take a little look. Fig required. No errors, but that's fine. Let's see what happens. So now that we have that, we can go our namespace. It's just going to be Scion file system. And we're going to have our class, and it's going to be JSON or JSON Serializer. Cool. So let's do our private, public, and control KD. All right, so let's just do the private first. We're going to have a few variables. So we're going to want to hold on to the file stream that we're writing to, and this will be closed in the destructor. So let's go std fstream. That's just to be m file stream. Cool. Then we're also going to need a Rapidjson string buffer. So the Rapidjson string buffer is going to hold on to the entire JSON string that we'll be creating. So we can say Rapidjson string buffer m string buffer. Cool. Now I don't know why this isn't seeing this right now. So I'm just going to try to build and see what this says. Cool. So rebuild succeeded. I should be able to see this stuff now. There we go. So we just had to make sure that the CMake cache and everything was, all the files were written in correctly, but now we have it, so let's continue. Then we're going to need to create a unique pointer to a Rapidjson pretty writer. This will help us format the JSON nicely. So let's say std unique pointer to a Rapidjson pretty writer, and this is going to be a Rapidjson string buffer. Okay, we'll call that MP writer. Cool. We're also going to want to keep track of how many objects and arrays that we have started to ensure that they have all been opened and closed or ended correctly. Okay, so every time that we open one, we need to add to this value. And every time we close one, we're going to want to take away from this value. So that'll just be int m num objects started and m num arrays started. So an object will start with a squiggly bracket, and then we'll have to have it end. So every time that we add one or start one, we're going to make sure that we're ending one as well. And then arrays will start like this. They start with a square bracket, and then we'll end. So it's the same thing. Okay. So the constructor, that's what we're going to create now. That will control opening the file for writing. So we'll pass in the file name of the file that we want to open. So const std string, this will be a reference, s file name, or file path, we'll just say file name. And the destructor, we're going to have it take care of closing the file if it is open. Awesome. So we're going to want to create two functions for starting the serialization and for ending it. And these will return a Boolean value. So we want to make sure that we have the correct number of objects and arrays have been opened and closed inside of these. So this is where we'll check. Okay, so we'll say bool, and we'll just call these start document and end document. Or you can say start stream, end stream, same idea. So now that we're going to add in a couple more functions that will start our objects or our arrays for us. These will also return a reference to the JSONSerializer. That way we can nicely change arguments together if we want to. All right, so let's start now. So let's go JSONSerializer reference, and it's going to be start new object, and it's going to take in a const std string reference for the key. Now the key can either be, we're going to have it as empty, or an empty string for now. So not all objects need to have a key. Sometimes they're going to be inside of an array and they won't need a key. They'll just be an object and they'll basically have an index. Okay. So we can copy this down and we can just say end object. And object doesn't need any arguments. And we can copy both of these, paste them down. This will be start new array. Now with an array, I don't want these to be key optional. I want them to always have a key, and then we'll have end array. Cool. So now I want to create a function to add key value pairs, okay? So this is going to be another template function. The reason why I want to make this a template is because the Rapidjson pretty writer has some functions that will write the value as an int or a string or a double for us. And I don't want to have to write that out every time. And I want to have the compiler figure it out at compile time which one it should choose. So we'll do that right now. So we'll say template, and it's just going to be type name, and it's going to be t value. Cool. And we're going to say JSONSerializer reference, and it's going to be add key value pair. And it's going to say const std string reference key. Now the key is always going to be a string. However, the value is what can change. And we can say const t value reference value. Cool. So now that we have this started, let's create two new files. One is going to be the JSONSerializer.cpp, and one's going to be the JSONSerializer.inl file. So let's create those now. So in here, we'll create the inl. So add new file, JSONSerializer.inl. Then we'll go to our source, add new file, JSONSerializer.cpp. Cool. So both of these, I'm going to want to include, this one's going to be Scion file system, serializer, JSONSerializer. And then we're going to put our namespace. So name space Scion file system. Cool. So let's just copy actually all of this and go to the INL, paste that in, and we can actually just remove all of that. Cool. Let's make sure these were added to our CMake file. So right here, it looks like the .cpp file was added, which is great. Now, I'm not sure if we need to include INL files, but I'm going to include it anyway. So we can just copy this down a line, change this to INL. Cool. So let's generate our cache. This is slow today, but that's fine. Awesome. Looks like we got no errors. And let's go and make this here. Control period. And it wants to make it in line here, and that's fine. We'll just make it. And then I'm going to actually grab this, take this from here, go to my INL file, and paste it inside. Then I want to go back here, and I want to include that here. Include JSONSerializer.inl. Cool. Now these, I want all of these to go in my CPP file, and it should see it. Control and create. Let's check our CPP, and they're all in there. Beautiful. Cool. So we'll do these after. Let's actually do this function first. Okay, so the first thing we're going to want to do here is actually add the key, because it's add key value pair. So we're always adding the key in, and we can just say mpWriter key, and it's going to be key.cstring. Awesome. If we open up the writer, you can see, you go mpWriter, and it has different functions it can call. It can call string, bool, double, end array, all these things for us. It's int, int64, blah, 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 all these stuff. Now, I don't want to have to write all of that. I want the compiler to figure that out for us. So what we can use to determine the type that we're sending in, so we want to know the type of the value so I know which function to call, we can use if constexpr. So we go if constexpr, and then we can say std is same v t value. Is this t value the same as a string? So if it is a string and we're passing a string in, we can do this here. I can say mpWriter string. That's going to write that string. And I can say value.cstring. Right? And if we copy all this, paste this in, go else, then we're going to do the same thing. We're going to say, is it an int? Or you could say, is it, or std is integral v. But there's two types of functions. There's int and int64, and we could handle that. Matter of fact, that's what we'll do. So we'll just make every int an int64 in this case. I don't think it matters. If you want, we could just make it std is same and then say int here, and then call int. Get rid of this. Or you can say std is integral v. Get rid of this. And then if it is an integral, we're just going to send in int here. Doesn't matter. Or we can say int64, right? We can do the same thing for unsigned values. So we can just copy this down. Paste that in there. Is unsigned v t value. This is going to be uint64. Right? In this case, we're just automatically setting everything to int64, or we can just automatically make it int or uint. It's up to you. Or we can add in different same as values. It's up to us. So we'll just leave this for now. Let's just say 64. What's the worst that could happen? If we have to make changes, we'll come back and make those changes. So let's do another one here. Copy this down. And we're going to say, is the value a floating point? So is floating point v. Now, the writer only has double. It doesn't have float, so it only handles doubles. But we can control the number of decimal places, and we'll do that in the JSONSerializer constructor. Now, we can either pass it in, or we could just have a value that we default to. Then we're going to want to say else. And right here, we're going to do static assert, and we're just going to say false. And it's just going to say type is not supported. Cool. Okay, if you've noticed, we don't have one for bool. The thing is, I tried to get it to do the check with std is same with bool, but it never actually worked for bool. It would just make it an int or a char or something of that nature. It never actually, for the bool, it never actually worked. So what I want to do to handle that is create a template specialization specifically for bools. That way the compiler will have a better idea of what to do when a bool value is passed in here for value. So let's go back to our JSONSerializer, and we can just copy this down, right? And take this here, and instead of t value, it's going to be const bool. Okay, and I wonder if this will make this in the inl file for us, and it will. Cool. All right, so here now we want to add in our key. Get this here. Might as well paste that in. Paste. And MP writer. We know this is a bool because we're passing in a bool, and that's the value. Awesome. Now we forgot something. You guys may have caught this already, but we forgot to add something in here. We're returning the JSONSerializer. So what we need to do is return this. And we need to do that up here as well. Awesome. Okay, hopefully that makes sense. I don't think I missed anything. But what we're doing here is we're allowing the compiler to pick the type for us. It's going to look at the type. If it's an integral, it's going to go in here. If it's unsigned, it's going to go in here. And if it's floating point, it's going to go in here. And if it's a string type, it's going to go right here. Okay, so that works for us. So now that we have this, let's actually go to our CPP file and start working on that. So like I said before, we're going to want to have the CPP file handling opening the stream. So let's actually do our initialization right now. So m file stream, m string buffer. Now let's do our writer. So mp writer, and this is going to be std make unique of the rapid JSON pretty writer, and then it's rapid JSON string buffer. And that's going to take in our string buffer. Cool. Then we're going to have our num object started. And it's going to default to 0. And num array started. Cool. So the first thing I'm going to want to do here is open the file. So we're going to go m file stream dot open, and we're going to take in the file name. So s file name. Now we want to set our open mode, and for what I want to do here is it's an output, so it's std ios out. And I also want to, if the file already exists, I want to erase everything that's there and rewrite to the file. So we're going to want to truncate. So we go std ios trunk. Cool. Now I'm just going to want to do assert here. Scion assert. So in order to use assert, we need to include our logger. So include logger, logger.h. So we have our Scion assert, and we want to assert if it's open or not. M file stream dot is open. We want to make sure that it's open. Failed to open file. Cool. However, we're going to go a bit further than that. The assert's going to work for us. I'm going to want this to assert in debug. However, in release, we're going to have this throw. So we're going to say if not m file stream dot is open. Whoops. We're going to throw std runtime error fmt format JSON serializer failed to open file as file name. Cool. even though we're in release right now, all your testing, like every time you're like, so whenever we do our creating a file or writing to a file, this should always work. So that's why you always want to put in some asserts, and we should be testing in debug. Now you don't want to run in debug, but you want to test. All your tests should be done in debug for sure, and then go to run it, release later on. Now we want to set the max decimal places when we're writing our doubles or our floats. So we're going to go MP writer, and it should be valid here because we did this in our initialization. You could put a check in if you like, but I believe it'll work. And set max decimal places. Now there's also other sets you can do. You can set your format options. You can set the style of indent that you want, but I don't care about that. Feel free to add that stuff in as you need. So we're going to set the max decimal places, and this is just an int value, and it shows here what it would end up with based on your settings, okay? So what I'm going to do is we can either pass this in as an argument here. I'm just going to make it a constexpr value. So constexpr int max decimal places, and that's just going to be 3 for me. Feel free to change this or put it to whatever you want. And we're going to put that in here. Cool. Now we can also pass it in if you feel. If you want that to be changeable, it's up to you. But if it's not capped, it'll be like 8 or 9. I'm not entirely sure how many. Okay, so let's do the destructor. And all this is going to do is check to see if the file stream is open. And if it is, it's going to call the close. So if m filestream.isOpen, m filestream.close. Cool. All right, now start document. First thing I'm going to do in the start document is actually do an assert. So Scion assert, and it's going to be m num objects is equal to 0. You don't want to start the document and have objects already created. And here we're going to say and document has already been started. Please reset the serializer. Cool. And we're going to want to add an error for that. So say we're not in debug. I don't want it to throw here. Oh, I guess we could throw. But I'm just going to add an error. So we're just going to say m num object started is not equal to 0. I'm going to do the same thing here. Just copy this down. Change this to error. And get rid of this. And just return false. So if we get to here, we want a plus plus m num objects started. And I'm going to want to start an object. And that's basically a table will be an object. Okay. So we're starting our new object or our new document. So we'll want to return mp writer start object. Awesome. Now the end document will be close to the same. Okay. We're going to have 2 asserts in this one. And we're going to say, we can actually just copy all of this here. But this we need some opposite stuff. So we want to make sure the num object started is equal to 1. Because, okay, or when you start the document, it is an object. So you have your object that holds on to it, right? Let me show you here. So say we have this. So when you start it, it'll have this. And when you end it, it'll have this. And then you'll have some stuff in between, right? Then you'll have like stuff. And then that could be this here could be an array. And that needs to end as well, right? So this goes here, the array. So we're counting these things. So this needs to be started, and here could have another object, right? So you have an object inside of here, object with some more stuff, right? Inside of here, and then you might have another object like so, right? So this is our first, and this will be the end, always. So if we create more in here, but you forget to call this one, our counts could be off. Same with arrays. So we want to make sure that we always have 1. By the time we get to the end, there should only be 1 object left open, and that's the last one to close, okay? But so we want to change this error here. There should only be one object open. And we're going to want to copy this line down. And if our arrays needs to equal 0, so we'll say 0 here. Num arrays. Because by the time this gets to the end of the document, we want to make sure that we have no opened arrays. This should be closed by now. Okay, so here, too many arrays started. Did you forget to call end array? Awesome. That's a question. So we'll have our errors. So num object started is not equal to 1. We want to say something like this. We can say failed to end document correctly. There should only be one object open. Did you forget to call end object? And we can copy this line down. Change this to arrays. This has to equal, if it's not equal to 0, failed to end document correctly. Too many arrays started. Did you forget to call end array? Cool. We want to end our object, so we just say mp writer end object. And then we want to write the string buffer, whatever was written by the pretty writer was written into the string buffer. We now want to write that to the file stream. So we're going to go m file stream m string buffer get string. Then we can say m file stream flush and then return true. Now I'm not sure if we need to flush here, but we can flush anyway. So now we only got these 4 more to do. That's good. So let's do the start new object. So the first thing I'm going to want to do is actually increase the num objects open. So num object started. Then I want to check to see if there is a key. If the key is empty, we'll just ignore it. But if it's not empty, we're going to write the key. Okay, so if not key.empty, we're going to go mp writer key.cstring. That way, if we have an empty table or a table that doesn't have a key, we can just say start new object. And then mp writer start object. Return this. Cool. So an end object, it's going to be pretty close to the same, but I want to put a little assert in here. So I want to say Scion assert. And I want to say num objects started is greater than 1. Why greater than 1? Because when we start a document, it's already been started. Okay? So if we could call end object too many times, and that would wreck it for us. So we don't want that. So end object called too many times. Awesome. So from here we can subtract from our num objects. Num object started. Cool. Then we can write end object. mp writer end object. Then we can return this. Awesome. All right, so we basically want to do the same thing for the next 2 functions. So we can just copy everything over and go from there. So let's copy this. Start array. This one I decided to always have a key. And want to say start array. Change this to num arrays. Cool. and then end array. You can just take this end object, paste this in here. And we want to make sure num arrays is greater than 0. Num arrays is greater than 0. And array called too many times. Num arrays started and object return this. Nope, and array. Awesome. Let's change this to a function. Cool. All right, there we go. So that's it for the JSON serializer. We can get rid of this comment here. We don't need that. And did I miss anything? I guess we could make a reset function as well. Actually, let's do that. So let's go to our JSON serializer here. We'll just create another one, bool reset. We'll have this reset based on a file of a new file. Okay, so let's make this. All right. So if you want, pause the video here and try to do this reset yourself. So basically we want to do the same thing here. We want to open, we want to make sure that everything is opening for us. We want to reset everything back to 0. Maybe do some checks to make sure that it's okay to reset these back to 0, right? Like, so in our end document, we're doing these checks. Maybe do all these checks as well. And then all you have to do is close the file and go from there. Cool. So what we could actually do here, if we just say num object started and minus minus, it should equal to 0 now. So basically everything's been reset. Flush has been done. All we need to do in the reset is actually close the file. So we can say, we can actually grab all this stuff here. All this, if we want, just change this here. Cannot reset with, cannot reset arrays, too many arrays open. Cannot reset document has not been finished or closed. That'll do. Not equals 0, not equals 0. And we can just do all this. Cool. Turn true here. Then if we just go back up to the top, we can actually just copy this. Don't need to worry about this. Go back to our reset, paste that in. There you go. It's ready to start over again. Taking in the new file name here, opening the file stream. Cool. Actually, let's also assert. Let's actually close the file. So if file stream dot is open, let's close it, and then we'll open it again. Now I believe this, you can do this with no issue. Cool. I think that's good. And then you can just start over again. All right. I haven't tried this, so maybe give this a try and see if that works. If not, we'll fix it. Let me know in the comments below. So I'm just going to do a quick build to make sure everything builds without error. Okay, build. Awesome. So build succeeded. No issues, no errors, no warnings either. Interesting. So yeah, that's great. So now that we've done this, we're going to want to go to each component and create serialize and deserialize functions. Now we can either do this in the component themselves or create another class that'll handle that for us. Now, if we put it into the component themselves, we're going to have different serializers, and we'll have to have those or a reference to those or something in that in the component. And I don't think the component needs to know what a serializer is. Like right now, we already have the soul in there. So if we go to our components here, ECS, any component, doesn't matter. We already have soul. Like it doesn't need to know about soul, but we did this anyway, and we did it in the component because it's easier to do it right here. However, when it comes to the serializer, we don't need to do that there. So what I want to do is actually in components, I want to create something called the ComponentSerializer, and we'll handle all of that inside of this. So let's do that now. So add new file, and it's going to be ComponentSerializer.h. Cool. That way, everything that we need to add can just go in this ComponentSerializer.h. We don't, this ComponentSerializer can hold on to all that information. We don't have to be putting, eventually we'll have a Lua serializer. We don't want to have to put that into each component and all of that. So we'll just handle this from here. So now we'll just add in our pragma once. And we're going to have our, since this is in our core now, because yeah, we did this in core. Hopefully you guys are paying attention. Hopefully you guys saw that. So we were in our core. So we want to have our namespace, Scion core, and this is in the ECS. Okay. And I'm going to have a class. We're going to call this ComponentSerializer. All right. Okay, so I'm going to need to forward declare some things up here. So we'll say namespace, Scion file system. And we're going to have our class, JSONSerializer. Eventually, we'll have the Lua serializer here. We'll try to do that in the next video. Now, this is one of the only times I actually want to put the public at the top. Now, the reason why I usually don't, just because I'm used to putting private first, but we're going to have a lot of private functions that are not necessarily needed outside of the ComponentSerializer, and you'll see in a minute what I mean. So we're going to have our public, and all of this is going to be static functions. So we're just going to delete our constructor. So ComponentSerializer, delete. Cool. And I'm going to want to have some more templates. So this one's going to take in, we're going to do our serialize function first. So we're going to say template, and it's going to say type name, and we're going to have T component. And then we're going to have type name T serializer. Like what type of serializer are we using right now? Serializer. Cool. Izer. I think there we go. And it's going to be static void serialize. And it's going to take in the T serializer first. And that's going to be a reference. The reason why it's a reference and not a const reference is because we're writing to something, right? So we need it as a reference. Serializer. And we're going to take in a const T component reference for the component. Cool. All right, and we're going to have another one, and this one's going to be for deserialize. Now, deserialize is a little bit more complicated because we're going to be sending in a serializer. You can't overload based on the return type. So we have to change a few things to get this to work for us, but we'll go over that right now. So template, and it's going to be type name T component. Then we're going to say type name T table, okay? Now, what this is going to be is your soul table or your Lua table or your JSON value. Okay, so we'll go over that when we get there. And we're going to say static auto deserialize. And it's going to take in a const table reference table. T table, sorry. All right. So I'd like to do the same thing and create an INL file. So let's do that now. Right here in our components, add new file, ComponentSerializer.inl. And we're going to add our pragma once. Namespace, Scion core, ECS. Actually, we don't need, do we need pragma once in INL files? We're going to leave it off for now. And I'm going to say component serializer.h. Cool. Let's go to our CMake list. It probably wasn't added in, and that will be in our core CMake list here. So we probably have some new stuff added. We do. Down here, we have this. Now we could make a new section for this, or just put it here for now and we'll fix that up later. Just put a little space and we'll put our INL file. Cool. You know what? We're also going to quickly create the CPP file. We might as well, because we're going to have to put some functions in the CPP file. So it's source, ECS, components, add, new file. And that's going to be ComponentSerializer.cpp. Cool. And that's going to be include core/ECS components ComponentSerializer.h, not .inl. And that's going to be namespace Scion core ECS. Awesome. Let's make sure that went into our CMake list, and it did. Very nice. Cool. All right, so I'm just going to want to create both of these functions right now and then move them where we need them to go. Cool, I created them here, so let's take them out of here. Go into our .inl file, paste them in. Same as we did before, and then down here, include our INL file. So include ComponentSerializer.inl. Awesome. All right, so let's go into here. And the serialize function is actually pretty straightforward. So all we're going to do is we're going to create a new function, and we're going to call it Serialize component. Okay, Serialize component. That's going to take in the serializer, and it's going to take in the component. Now this one's easy because there is no return value, right? So the return value doesn't change, it's just exactly the same, but our arguments will change. The serializer can be different and the component can be different, so we can use the same function and it'll allow us to overload it. It'll know which one to grab. Deserializer, on the other hand, is not as easy. Okay, so we're gonna have to put in some constexpr if checks for this. And we're gonna have to return specialized functions. I already tried it, and so say we want to create a deserialize function, but the only thing that's changed is the return type. It won't work because the compiler is looking for a difference for the arguments. It can change based on the argument, but it can't change based on the return type, okay? But for serialized component, it'll work fine because the arguments will be different, okay? So since we're doing JSON right now, we don't really care about Lua yet. We'll just do our JSON stuff first. So JSONSerializer, cool. And we can say static void, and we're going to have serialize component, and it's going to be Scion file system JSONSerializer reference, and we're just going to call this the serializer. And then we're going to have our component, and the first one we're going to do is a transform component. So const transform component reference transform. Okay. Now, what is the transform component? It doesn't know. So we need to go up to the top right here and include all components. KD. Awesome. So we have our serialized component, and we can copy this down a few times. We're going to have our transform component. We're going to have our sprite component. Those are really the only ones we care about right now. And then we're going to have our animation. Then we're going to have probably the box collider. Box collider text component, text, circle collider, let's move this one. So circle collider. Let's move this one beside the box collider. Cool. We're going to have our physics component. Copy this line down. Physics component. Call this physics. We're going to have a rigid body component. Rigid body. Cool. And we can just add more components as we have them. I think that's good for now. So we have all these functions that we're going to have to finish. Now, when it comes to deserialize, now we can't do this. I'll show you. So say we have static transform component, right? Deserialize. And if I say const Rapidjson value reference, and it's going to be JSON value. Now we don't know what that is, so up here we have to add that in. So we can go include Rapidjson, and we want document. Cool. Now you can either call this JSON value, you can call it table, because we're going to be using it here, and it's basically going to be a table. My brain goes to table because of Lua. That's capital V. Cool. So say we have the transform component. Well, if we copy this down and we just say sprite component, you see we have an error. If you highlight this, it says function definition for deserialize not found. Cannot overload functions distinguished by return type alone. So we can't do this. Okay, so what we need to do for transform is say transform. We have to have a different name. Then we can say deserialize sprite. Okay, so let's add a couple more. Deserialize box component or box collider. Circle collider. Go back up a couple and let's add the animation. Then text component. Physics. And rigid body. Cool. So what we do, even though these have different names here, when we go to create Lua, they can have the same name and instead it'll be fine. All we need to do is overload it with the argument here. This will be a sole table. All right. So we also got to change this. This needs to be animation component, box collider, circle collider, text component, physics component, and the rigid body component. Cool. So now we have all these functions. We're not going to fill all these out today. We're only really going to care about the sprite component and the transform because that will be good enough. So let's create all of these in our CPP file. Now these should have all been created for us. Awesome. There we go. So now we got to fill these out. So before we fill these out, let's go back to our .inl and do our serialize function here. Okay. We're basically going to want to do the same thing that we did in our JSONSerializer here and use this constexpr if and check our types. And then we're going to want to return the correct function. Okay. So if we go here to our ComponentSerializer, I want to go if constexpr std is same v, and it's going to be t component transform component return deserialize transform, and it's going to take in our table. Hopefully that makes sense. And then we can just copy this down, else. And if it's not transform, we can say sprite component deserialize sprite. And do it for all the rest. And then we want to say else static assert false component type is invalid. Cool. Now it doesn't like this one. Did we name it that? Circle. Awesome. Looks like everything's good there. And that's it. And then we can just add components in as we need them. Okay. So this will return the auto. So it's going to return the component type that we're sending in. All right. Nice stuff. So let's go back to our component serializer here. And before we do any of these, let's actually make two quick macros that we can call. So right here, we'll just say define serialize component. That's going to take in the serializer. And it's going to take in the component. Then we can say Scion core ECS component serializer. Serialize. Serializer. And component. We don't want to put a semicolon here because this may be used in a function. Copy this line down. And we'll change this one to, let's put the serializer first. And just say comp. Here, right? And then we can say deserialize comp serializer. Cool. That should work. KD. All right. So now let's go fill in some of these functions here. So let's go here, and we're only going to care about the transform and the sprite for today. Okay. So what I want to do here is I'm going to go serializer dot. Now it doesn't know what this JSON serializer is, so we need to include that. So include Scion file system serializer JSON serializer. So we have our serializer, and we're going to want to say start new object. And this new object is going to be the transform. And we want to start another new object, and it's going to be the position. And inside the position, we're going to want to add key value pair, and that's going to be x and transform.position.x. So it will know what to do here. Then we want to add another key value pair, and this is going to be y transform.position.y. Now we want to end our object because we started a new object for the position. So end object. Then we want to add a new object or start a new object. This is going to be for the scale. Then add key value pair x transform dot scale dot x. Copy the line down. Dot y dot y. Then we want to end object, but we're not done. We want to add key value pair. And it's going to be for rotation. Transform.rotation, and then one more end object. This will actually end the object for us. Cool. All right, that's it. That's how easy it is. So we're basically going to go through all the components and do the same thing. Why don't you guys, as a challenge, quickly do the sprite component on your own. So if you think about it, looking at this object here, how is this object going to look? It's going to look like this. So we're going to have a new table, and inside of this table, so it's going to be in this, it's going to be inside of a, or it's going to be a new object. Let's actually make this a comment, so it's easy. So this is basically, it's going to be inside of components, And then inside your components, you're going to have a transform component, right? So you're going to have transform. And inside of transform, we're starting a new object, okay? And inside of there, you're going to have your position. Position. If you bring this down, bring that over, that's stay. That can go here. Inside of and there, you're going to have your position, okay? And then we're starting a new object. Bring that down, bring that in. Inside that object, this could probably be here. That could probably be here, sure. Inside there, you're going to have your position. Inside of position, you're going to have your key value pair. So X, and that's going to be equal to whatever value transforms at. And so it's like 450.f or .0, right? Then you're going to have another one down for Y. This here, this is going to be closed. Going to have a comma here, and you're going to have scale. Okay, it's basically going to be the same thing. Just so you can visualize this, scale is probably going to be 1:1. And then you're going to have a rotation. Rotation. And rotation is probably going to be, let's say 45.0 degrees, right? So this will be your transform. So what you will need to do is create one for the sprite. So take a look at it and think sprite. What am I going to need in my sprite table? So fill this out. Fill this out. So you got to think it's going to look like this. So what in the sprite? Is the sprite going to have tables? Is the sprite going to need key value pairs? So take a look at this, see how it's done, and try to fill out the sprite now. Okay, did you give that a try? I hope you did. But if not, no worries. Let's do it right now. So let's say serializer. Serializer. Dot start new object. New object's going to be sprite. Okay, then we're going to add key value pair. That's going to be the width. Sprite.width. Add key value pair for the height. Sprite.height. Add key value pair. Now it's the start x. So start x. Sprite.start x. Start y. Then we're going to have our layer. Then our texture. S texture. Texture name. Then we're going to have the UVs. Now, what are the UVs? The UVs is going to be another table. So, start new object. New object is going to be UVs. Okay, let's get rid of this. Now we need to add key value pair. Let's copy this down. And it's going to be U. Sprite.UVs. .u. V. Width. UV width. And then UV height. And then we're going to want to end our object or end our table. End object. And then we have color. Color is going to be another table. Okay. And the color is also going to have 4. So we can actually just copy all of this. Not sure why. There we go. Paste it in. So we have UVs, change it to color. Sprite dot color dot R, change this to R, G, B, A. Color dot, fill these in, G, B, A. Then we already have our end object here. Then we have one more, and that's for hidden. So is it hidden? Add key value pair. This one, be hidden, header, hidden, sprite dot be hidden. Awesome. Then one more, just the end object. That's it. All right, hopefully you guys got the same. So we start object, start object, start object. So we have 3 starts, so we should have 3 ends. 1, 2, 3. We're good to go. All right. I think we have everything. I don't think there's anything else for the sprite that we need. If you want, go through and fill out the rest of the components. And we're going to need to do this deserializing. Now, the deserializing is a little bit different. We're going to use a JSON value. Now, I'm not going to put any checks in here. I'm going to assume when we're reading the file, we're the ones that serialize the file. So it should already be correct, and hopefully nobody messed with it. But so let's go to do the deserialize now. And we're just going to do the same as the other ones, just the transform and the sprite component. Okay. So let's do the transform real fast. So transform. I could have kept that, open that up. So we have our transform, and we're going to return this here. So what I need to do is return the position, dot position, and that's equal to glm vec2, and it's going to be the JSON value at position at x. And we want to get float, because it's a float. So we want to do the same thing for y, so we can copy all of this. Paste, change it to y, get float, cool. So that's our position. So we can actually copy all of this, paste it in, change position. This needs to have a comma here, sorry. This should be changed to scale, KD, to get it lined up, and go through and change these to scale. Scale. Cool. And we got one more comma here, and that's for rotation. And that's just JSON value at rotation. And that's also a float. Get float. Cool. KD. All right. So that's transform. So you need to do the same thing for the sprite component. Now, do you guys want to take a challenge and try to do the sprite component yourself? It's a little bit more complicated, but it's the same idea. Give it a shot now and see if you can do that. All right, deserialize sprite. Let's do this. So the first thing is the width. That's going to be JSON value at width dot get float. Width's also going to have the height. We can copy this. Height. Then we're going to have our UVs. And that's going to be equal to, not width here, UVs, then dot U is equal to JSON value at UVs, U, get float. Let's bring this down a line, copy this down, down, down. These are all floats. V, UV width, UV height. Change these. Dot V, UV width, UV height. I forgot to put the commas. Cool. That's the UVs. Now we have our start x dot start. Oh, we're still in the UVs, comma dot start x. That's equal to JSON value at start x. Get float. Same with start y. Oh, why is this one angry? So start x is an int. I'm glad it caught that. You guys probably caught that too. But we fixed it there. And layer, also going to be an int. Change this to layer. Just make sure everything you're grabbing here is the same that you serialized it above. Make sure it's the same way. Okay. Layer. And then be hidden. We can copy this line down, just change it. Be hidden. Get bool. Now texture name. JSON value at stexture. Get string. All right, I think that's it. KD, and we're good. All right. So that's it. So we have our deserialize, we have our serialize, we have all these other components that we need to do. But I'm going to leave that to you guys as an exercise. In the next video, they're already going to be filled out. But that's an exercise for you guys to try. We can get rid of this. Cool. All right. So we've actually gotten pretty far. There's one more thing that we have to make. Like we got all this. Let's actually just build right now to make sure it works. So we'll build. Okay, so it doesn't know what these are. It's because I spelt it incorrect. Right here. All right, try build again. All right, so the build succeeded. So now we can't do anything with these right now. Like we have all this stuff. We have these two. Oh, this will say serialize. Let's change this. Serialize component. So we have all this. So all the user needs is these two functions here, and it should handle it all for us. We want to be able to load the tile maps. That's the whole point of creating these serializers. So let's create, inside of our Scion core, let's create another folder, and we'll call this loaders. Okay, and inside of loaders, we're going to add another one, new file, and it's going to be tilemap loader.h. And we can do our pragma once. Okay, and we're gonna have our namespace, and we can say Scion core, and let's put this in the loaders. All right, and we're gonna have our class tilemap loader. All I want to include for this one is include string here. We're going to need that for the file names that we're going to send in, or tilemap names. And I'm going to want to say namespace Scion core ECS, and we're going to want the registry. Why do we want the registry? Think about that for a second. So I want to save and load tile maps. What takes care of all the entities for our tile maps? That's our registry, right? So we need to have a reference to the registry. So here we can create our private, and we can create our public KD. All right. So our tile map loader, it could just be default. Same with the destructor. We're not really doing too much with that. All right, but we're gonna have two functions: bool save tilemap, and that's gonna be Scion core ECS registry reference registry. Then we're gonna have a const std string reference, and that's gonna be tilemap name. Tilemap, not tilemap name, tilemap file. Cool. Then we'll say bool b use JSON. Okay. That's equal to false. So at first, we're going to default to using Lua eventually. I don't know why I did JSON first. I just felt like doing it first. Probably because it's a bit easier to create the serializer. And we're going to make another one, and this one's going to be load. It's going to basically have the same signature. We'll change this to load. So why do we want to have these JSON here? Because I want to have some private functions. So we'll say bool save tilemap JSON. Then we can copy basically this entire thing here except for JSON. And we're going to have the same thing for load. Load tilemap JSON. Then we're going to put a to-do. Save and load functions for Lua Serializer. Cool. So let's go and now create a new folder inside of this. So let's go to our source and create a new folder. Add new folder, loaders, and add a new file. Add new file, tilemap loader.cpp. Cool. This will include core loaders, tilemap loader, name space Scion core loaders. Is that what I called it? Yep, loaders. And let's create all these functions in there. Cool. Go to tilemap loader. All right. So save tilemap, we'll go if b use JSON return save tilemap JSON. That's going to take in the registry. That's going to take in the s tilemap file. Now right now we don't have an else, so we'll just say return false otherwise for now. Let's copy this. Eventually we'll have an else, we'll have save tilemap Lua, but we'll get to that. Paste this in here, and this will be load. Okay, so now we have these two functions. So we need to do a save and load. Now that's going to be your challenge, okay? I would go through it, but this video has already gone on pretty long. So we'll go over this in the next video. So what I'd like you guys to do is figure out how we can use our new JSONSerializer and our new ComponentSerializer, and how we can actually serialize and deserialize everything from JSON. So what we need to do is you'll have to use your file dialog inside of the menu. Let's go to that here. And that's in the editor. Sign editor. Not assets, sorry. Editor, displays. So right here in your menu display, we're already doing this. So just add in your serializing stuff here, your tilemap serializer, and try to actually serialize it to a file. First thing I recommend is you do your save. So try to do the save here. So if we copy this down here and change this to save file dialog, auto file, and save tilemap test. You can do the base path, sure. Then this, we want this just to be Lua. .lua, and we want to say if file dot empty. So if not empty, to do save the tilemap. Okay, so try to do that. So what you're going to do is you're going to open up a Lua file, and you're going to try to save that file. After you do that, open up your Lua file. No, sorry, this isn't Lua. This is JSON. We want to save JSON. Lua will be next. So tilemap save JSON file, and then we want to save the tilemap. Then after you do that, you want to make sure that you open up that file that's saved and make sure it's valid JSON, and that it looks nice and clean, lists out the components, lists out the different objects, closes it correct. I recommend you do this in debug to make sure that you open and close it correctly. Okay, so that's your goal. So what you need to do here, so you're going to need to create a new JSON serializer. To do create So I'll just write some steps here. So to do 1, create JSON serializer for the new tilemap path. 2, start the document. 3, start new array. You can name it whatever. Name it tilemap. 4, loop through all of the tiles from the registry. So what you need to do there is tile component with the view, right? So get the view and loop through the view. 5, inside loop, you're going to want to start a new object. And this would be a nameless. So start nameless object. Then start components, probably with like this, object. And then inside of that object, serialize all the necessary components. So that means you're going to have to check to see if the component exists, but the component will definitely exist for transform and sprite. There should be no tiles that exist without those two components, at least in our engine. So I would do some checks to see if we already have those components. Then you're going to want to end your objects for your component table, end it for the tile table, and then you want to end your array for the tile map table. Okay, so that'd be it for this, but then you want to end document at the end. Okay, so 7, end components table. 8, and the tile object table. Now this will still be inside the for loop. And then 9, end array and finish document. All right. And for the load tile map, you basically want to do something similar. You're going to want to go through and you're going to parse it. So I'm going to leave this to you guys. Do some research. See how you can parse a document or parse a stream from Rapidjson. And you're going to want to read the buffer. So you basically want to grab a string stream, read that file into a buffer, see what you guys can figure out. And you're going to be creating components here. You're going to be creating entities here. All right. You're creating the tiles. That's the hint I'm giving you. All right. That's it for this episode or this video. If you have any questions or concerns, please leave it in the comment below. Please like and subscribe. Your guys' support really helps. Let's change this to 9. Helps keep me going. This is great stuff. I hope you guys are enjoying this. Let me know below. And that's it. Take it easy.